Good evening. Let's solve the question that has been asked in GATE 2004. And the question is iron 2 oxide solid plus carbon monoxide gas giving iron solid plus CO2 gas. So basically this is a redox reaction in which iron 2 oxide, that is plus 2 oxidation state, is getting reduced by this reducing agent carbon monoxide. So it is now going to zero oxidation state, and the carbon monoxide itself getting oxidized to CO2. So there is the reduction of iron and oxidation of carbon from carbon plus 2 oxidation state to carbon plus 4 oxidation state. So this is the chemistry of this reaction. Basically this is a type of redox reaction. Carbon being a very good reducing agent will reduce the iron oxide to metallic iron and CO2 gas. Now equilibrium constant of this reaction is 0.435 at temperature equal to 1173 Kelvin. We know that equilibrium constant depends only on the temperature. It does not depend on the amount of the reactant or volume or concentration. It only depends on the temperature. And the temperature is 1173 Kelvin. Now, at equilibrium, what will be the number of moles of carbon monoxide gas required to reduce 1 mole of FeO at 1173 Kelvin? So in this question we have to calculate the number of mole of this carbon monoxide that is required to reduce 1 mole of iron 2 oxide to iron at the same temperature. So let's write this reaction, and this will be FeO solid plus CO gas, and this will be in equilibrium with iron solid, that is the reduced product, plus oxidized product, that is CO2 gas. Now initially at T equal to 0 we have taken 1 mole of FeO. So basically it is 1 mole of FeO, and we have to calculate the initial mole of carbon monoxide that is taken. Let's see, let we take x mole of carbon monoxide, x mole. Now this will be 0 and this will be 0. Now at equilibrium, when the reaction will attain the equilibrium, what will happen? All the FeO will get reduced to iron, because it is given that what will be the amount moles of carbon monoxide gas required to reduce 1 mole of FeO at 1173. So it will be now 0, and if it is 1 mole of FeO has been reacted, then this amount of CO will be left will be x minus 1 mole, and simple mole concept, that is 1 coefficient 1 coefficient. So 1 mole of FeO is going to reduce, then x minus 1 mole of the CO will be left, and iron form will be equal to 1 mole and CO2 form will be equal to 1 mole. Now K equilibrium, we can write it as, it will be concentration of CO2 divided by concentration of CO, because the equilibrium, in K equilibrium we have the activity of the solid as 1, so we will not write there. So it will be only CO2 gaseous product and reactant will be can be only written in the K equilibrium expression. So CO2 mole is 1 and CO mole is x minus 1, and K equilibrium given value is, that is 0.435. So we will just equate it with 0.435, and from this we will find the value of x. So value of x will be equal to 1 plus 1 divided by 0.435. So 1 plus, let's just find the value of 1 divided by 0.435. So sorry, one divided by 0.435. Let's find the value of this. 1 divided by 0.435, and the value is 2.298. So just we'll put the value 2 plus 2.298 So it will be 3.298. So it will be approximately 3.3 moles. So in this reaction we need 3.3 mole of carbon monoxide to reduce 1 mole of FeO. Thank you. So the correct answer will be option D.